Hi, my name is Chris Foote. I'd like to welcome everyone to today's presentation. We'll be recording this presentation and providing it on RDX's YouTube channel. I also have Ike Wagu with me, who is on RDX's MongoDB Support team. Ike and I will be able to answer questions you have on the MongoDB product. Since we're using GoToWebinar, to ask a question, you'll have to hit the little button beside your name. That'll let me know that you have a question. By default, GoToWebinar mutes all participants except the speaker, which is kind of a good thing because it reduces the chances of background noise affecting the presentation. We've all been on conference calls that were affected by wind, traffic, sirens. Just hit the raise your hand button next to your name and I'll unmute your session. If you've ever seen my LinkedIn profile, you can pretty much tell by my hair color that I've been in the business for some time now. I actually worked on the first NoSQL databases 20 years ago. IBM's IMS, which was hierarchical, and Codicil's network database system. Neither of those databases were relational, but I was around when relational systems first became popular. I had the good fortune of working with the first commercially viable releases of both IBM DB2 and Oracle. At Bank of New York Mellon, I was a member of a team that built one of the first large-scale financial apps on IBM's relational platform. As I started to build RDX's NoSQL practice, I began to notice some interesting parallels between the adoption drivers for NoSQL as I did 20 years ago for relational. Flexibility, ease of use, lower total cost of ownership, faster application development. What I'm finding is the same initial adoption drivers are applying to both relational and NoSQL systems. This is what we're going to cover in today's presentation. We'll begin our discussion with a quick intro to the NoSQL adoption drivers. When I was asked to launch our NoSQL support practice, I performed a traditional comparison of the various NoSQL vendor offerings. I generated a weighted list of evaluation metrics to compare the vendors. I've been doing evaluations like this for over 20 years now. I'll provide you with some of the reasons why an old relational guy chose MongoDB for our first initial service offering in the Why MongoDB section of the presentation. We'll continue our discussion with an overview of the RDX MongoDB Inc. partnership. In the next section, I'll provide you a high-level overview of MongoDB features and business benefits. That's really the key, the business benefits of the product. I'll follow that with a brief discussion on RDX's MongoDB support services, and we'll finish with next steps and who you can contact for more information. I've also written a series of relational NoSQL comparison articles on LinkedIn. Just search for Chris Foote on LinkedIn, find my profile, and you'll find about 6 articles. The series isn't complete as I have about another 10 articles or so to complete the series. Just send me a request to become a LinkedIn buddy and you'll get notified when the latest article is posted. One of the benefits of the newer NoSQL architectures is their ability to scale horizontally as well as vertically. We've been able to scale this middle tier architecture for some time now. When the application experienced an increase in the number of users, we were able to inject additional servers into this middle tier. It's been more of a challenge to horizontally scale the database tier. Both Oracle and Microsoft, as well as other leading DB vendors, they do provide clustered architectures. But they're expensive, complex to administer, and hard to configure for transparent application failover. So the most common approach we took as DBAs to increase performance was to add CPU memory and disk to the single database server. We added horsepower to this box. We increased horsepower vertically by adding CPU memory and disk. Or we migrated it to a server that had more horsepower. When I was evaluating NoSQL database architectures, one of the common themes I identified was their ability to easily scale horizontally. I was pretty skeptical as I'm a relational bigot by nature. But after reading the customer use cases and learning more about the NoSQL architectures, they are fairly simple to scale horizontally. Shops can reduce their database-driven applications' total cost of ownership by using the NoSQL architecture's ability to leverage low-cost commodity hardware. So instead of scaling the system horizontally, we're adding low-cost hardware and scaling the system horizontally. You just really kind of scale out when more horsepower is needed. We'll learn more about horizontal scaling in a couple of minutes. One of the leading adoption drivers for NoSQL architectures is their ability to easily store and process unstructured data. What we know is that not all data we want to store fits neatly into a relational table's rows and columns. RDX has a relationship with Gartner, and I went out to their website and took a look at some of their predictions for their analysts, and they're really predicting a kind of a veritable explosion of unstructured data generation that's going to be led by the Internet of Things. Other forecasts state that unstructured data is growing at twice the rate of its structured counterpart. Gartner forecasts are telling us that the amount of data being stored doubles every 2 years. So the example I'm using on this slide is a movie review. In the past, movie reviews were provided by an article written by a reviewer, 10K in size, pretty small. Now that article is accompanied with a movie trailer. So not only are we generating more unstructured data elements, by their very nature, those elements are often a lot larger in size than their structured data counterparts. So in this slide, we're taking a look at an example of a modern application. At the top, providing you with some industry forecasts by IDC and Gartner. Really what they're showing is that as IT professionals, we are going to have to contend with an exponentially increasing amount of unstructured data. So the application I'm showing displays geospatial, pictures, unstructured text. We can have a video component. These unstructured data types historically have not been easily stored in relational rows and tables. So here's a couple of quick examples of unstructured data on the left. We're going to talk about the single view of the customer here in a couple minutes. Sensor data, biometrics, radiology, patient healthcare data, all the different scans, CT scans, x-rays, of course videos and images, weather data, catalogs. All this data is unstructured, and we need a way to store it. As I stated previously, I performed a structured methodology. I followed a structured methodology to compare all the leading NoSQL vendors. One of the more important evaluation criteria was the potential scope of application. Was their technology able to support a wide variety of application requirements? So for example, Redis is an in-memory database. It's commonly used as a front end for relational database data store. So what you do is you beat the daylights of memory in the Redis database, and you store that data in a persistent data store, which is a relational database, MySQL, SQL Server. Neo4j is a graph database that focuses on retrieving data through the use of named relationships. Well, that's really good for social apps. Give me all the people who know Chris Foote. Give me all the people who are technicians at RDX and work in database support. It does have a very narrow scope of application. DataStax Cassandra, its focuses on high-speed access to very large and very denormalized data stores. What RDX want to do is select a robust general-purpose database that fit as many application processing requirements as possible. Being a relational guy, data quality enforcement using database-driven constraints was important, but I also wanted to leverage NoSQL's Agile development features. RDX wanted an offering that helps our customers speed application time to market. But we don't want to provide this capability at the expense of data accessibility. We want our database to easily respond to queries without complex coding and storage techniques. The database needs to be able to easily answer the questions that we ask. We also want the database to be able to leverage low-cost hardware to scale horizontally. We want to help our customers reduce database TCO. In addition, we need systems that provide high availability without increasing system complexity and cost. We also wanted that offering to have a 24/7 product support option. MongoDB Inc. provides that support as part of their suite of product offerings. We wanted to give our customers the ability to choose from open source crowd-supported software and vendor-supported database products. If our customers are going to run critical apps using a database we support, it's important to provide them with a database product that has the option for 24/7 product support, patches, upgrades, break-fix assistance. If we run into a problem with a product at 2 a.m., do we want to be forced to search discussion forums for an answer, or do we want the option of calling the vendor? We can leave that choice to our customers. After selecting MongoDB, I approached MongoDB Inc. about a partnership in the middle of last year. RDX is going to provide the traditional DBA monitoring and administration services. But if our customers are looking for development assistance, not DBA support, we feel that MongoDB's app development consulting services, that offering will ensure the success of our customers' application builds. RDX is going to provide the services that all good DBAs do to support developers. We just didn't want to dilute our focus by providing application development support services. We aren't developers. We're DBAs who help developers build stuff. Here's some MongoDB fun facts. If we can see the product's popularity, 10 million downloads, 35,000 user group members. Now that RDX is a partner, we have 1,001 technology and services partners and 2,000 customers across all industries. If you go to the MongoDB website, you'll see the logos from the hundreds of companies that use their product. It really does read like a laundry list of who's who. eBay, Google, Amazon, Facebook, Adobe, Verizon, Viacom, Cisco, Expedia, AOL, MTV, MetLife, Craigslist, NBC, Shutterfly, Edmunds, the Weather Channel, Forbes, eHarmony. A pretty strong collection of companies are using the product. I also reviewed the vendor's position in the marketplace. Were they growing? Would they grow in the future? Took a look at the Gartner analyst predictions, database engine websites. So here's the output from a database engine website. And we can see that MongoDB has a strong growth percentage and is among the top 5 most popular databases. MongoDB provides driver-specific manuals for the more popular application technologies that access its data store. You can go online, and you don't need a license to access the MongoDB documentation. So you can find the administration guides, but you can also find guides for Python, Java, Node.js. The mean stack can be compared to the MySQL LAMP stack. Mean stands for MongoDB, Express, Angular.js, and Node.js. Let's take a look at some of the performance statistics I found. We can see that MongoDB is able to handle a high number of servers. There's a company that in its MongoDB cluster has 1,400 servers. This implementation has 1,000 servers. It can also handle a high number of concurrent users, 300,000 ops per second, 500,000 ops per second. It's also able to accommodate a very large volume of data, very large data stores. For example, Carfax has 13 billion documents stored in its MongoDB cluster. It's a lot of documents. MongoDB stores data in JSON documents. I'll show you an example of inserting a document in an upcoming slide. The first time I saw a document being inserted to MongoDB, I was trying to find out where the document's definition was. I was trying to compare it to an Oracle table definition, which has to be built before you insert data into it. Well, the tech giving the demo told me there wasn't a definition. The document schema is automatically created when the document is inserted. You insert the data, and MongoDB creates the schema during the insertion. You don't need to predefine it. A document can be loosely compared to a row in a table, and a group of related documents is a collection in MongoDB, which can be compared to a relational table. The difference is that as a relational DBA, I have to pre-create the table before the developers can store data in it. But in MongoDB, we don't have to predefine the structure before storing data. Kind of just takes what you insert and stores it accordingly. So really it's a comparison of relational's pre-described schema and MongoDB's self-describing schema. So on the relational side, the schema has to be built before the application is developed, and it has to be pre-created before we start inserting data. It also enforces data structure. Your rows can't deviate from that predefined schema. And when you need to change that schema, you have to coordinate those changes with the database and the application. On the MongoDB side, there is no schema required before you insert data. It's created each time the document's inserted. And each document in that collection can have a different set of fields, and I'll show you an example of that. That allows us to iteratively evolve the schemas during the application development lifecycle. So here's the example. It's a life insurance policy. It's going to highlight the benefits of a flexible schema. When you call the MongoDB insert method using these specifications, it stores the information. You'll notice that our documents have some common fields at the top, but fields that differ based on the policy type. So for clarity in our example, I include the column, our common fields, top of the document. These are probably the fields that we want to index for fast retrieval. Policy number, type of the policy, customer identifier. Then we have some fields that are unique to the type of policy, and they're different because we want to store different information about an auto policy than we do a life policy. So for the auto policy, we wanted to store the field deductible, the make of the car being insured, the model, VIN number, life insurance policy, policy value, start date, end date. As a relational DBA, because the data we're storing is different per policy type, I would build a separate table for each policy type. In MongoDB, I can have a single collection of documents with a policy type and fields that are dependent upon that policy type. We can index any of these fields, but traditionally you would index the common fields, which I've placed at the top. Doesn't mean that you can't index these fields if you have the need. What happens when you report on all the policies for a customer, and that customer happened to have lots of different types of policies? I'm a car guy. Let's use General Motors or Ford as an example. They have dozens and dozens of different policy types that range from cyber insurance, equipment, key man policies, physical plant. In a relational system, I would have to join all these tables together to get that common view of the customer. In MongoDB, we can store our common information we want to search on at the beginning of our document, and then store the dynamic information that pertains to that specific policy type below it. We can use indexes on the fields that we want to speed search access, but still be able to leverage the flexible schema. I would access one collection and be able to get all the different policies for a given customer. Here's an example of the types of queries that we can run against MongoDB. On the upper left, we see that the document contains different types of data: text characters, numbers, geolocation. We can also store an array in a field. We can also have sub-documents in our main document. In this example, we can store as many sub-documents in our main document as Paul has cars. Well, Paul has a very expensive fleet of cars. He has a Bentley and a Rolls Royce. If he's Jay Leno, this would be dozens and dozens of sub-documents. The specifications to insert this data is pretty much how it's displayed. You name the field and you insert the data. It's pretty much all there is to it. We can then ask the questions in the lower right that include geospatial, find all the car owners within 5 kilometers of a given geographic point, text searches looking for leather in the model description, all using a fairly simple access language. We talked about one of the benefits of NoSQL architectures, its ability to store unstructured data, and we learned that unstructured data can be quite large, and in general larger than its structured counterpart. MongoDB uses GridFS to store large data values, videos, images. On insert, it decomposes the data into smaller chunks. When the data needs to be retrieved, it combines all the chunks together and delivers it to the requester. Since it uses pointers to the chunks, it knows where they are, so data access is pretty efficient. It also allows the application to choose where to start within the data element. For example, if you're storing a video, you can add metadata about that chunk and start processing the data by using the metadata to select the chunk for your starting point. Let's spend a couple of minutes on high availability using replica sets and horizontal scalability called sharding. So we shard in MongoDB for performance. You can configure MongoDB to use sharding, replica sets, or both. Let's talk about sharding for performance first. MongoDB partitions or distributes data to the different shards based on a shard key. The shard key is a field or set of fields in a document that's chosen by the user. MongoDB uses a shard key to distribute the data to the different shards. Let's take a look at this range partitioning option. As an Oracle DBA, range partitioning in Mongo was a little bit different than what I was used to. In Oracle partitioning, we hard code the upper and lower boundaries of values to distribute the data. We then specify a table space associated with that range. And a table space is just a collection of files. Oracle then sends the data to the table space that falls within that specified range of values. In MongoDB, you select a field or set of fields for your range key, but you don't predefine the upper and lower values for the range. MongoDB automatically chooses those ranges for you and then distributes the data to the shards. So we have a key coming in, and based on that key, it sends it to a specific shard. You can also use hash keys, or user-defined tags to determine how the data is divided up and stored on the different shards. The shard keys are built at the collection level, kind of like a relational table. So different collections can use different partitioning schemes. Think of a shard as a data store. And that data store can be backed up or duplicated to secondary servers. We can replicate the data from our primary server to one or more secondaries. MongoDB provides a balancing process which is used to keep the shards evenly balanced with data, so we don't have one shard that has more data than another. Since MongoDB tracks the location of the documents based on the shard key, it knows which shard to go to get the data you're looking for. Document shard locations and all kind of other metadata is stored in the config server. It knows where all the keys are stored in what shard. This MongoS instance caches our config server data. So MongoDB uses the term query router to describe this MongoS instance. One of the common implementations is to install a MongoS instance on the same server as your application, what I'm using here in this example. A client request is sent to MongoS, which then routes the operations to the shard and returns result sets back to your application. The application accesses the data in the shards by communicating with the MongoS instance. And retrievals don't have to search through all the different shards unless the query requires that multiple shards be accessed. So let's move on with replica sets. Here's an example of a replica set in a multi-data center cluster. We have a single collection that has its data distributed to 3 shards. So here's my collection, and for performance, we have 3 shards. We also learned that we can use replica sets to increase the availability of that sharded data. In our example, the shards are defined to be in a replica set that contains 2 secondary servers. Here's our primary, it's 2 secondaries. Our second shard, it's 2 secondaries. Now, each of the secondaries for our shard are stored in different geographic locations. In this case, different data centers. The secondaries are duplicates of the primary server's data. MongoDB replicates the changes from the primary to all the secondaries. All servers in the replica set can be assigned a voting priority and a number of votes. These settings are used during the voting process that selects what secondary will become the new primary in case that primary fails. Secondaries vote on which one of them should become the new primary. Since the MongoDB system itself knows which server is the primary, no application changes are required to point the application to the new primary. And once that failed server is restored, it can be added back into the replica set as either a secondary, or you can configure it to return to its role as primary. In addition, we can also configure our application to use a secondary server for read access. In this example, we have a Tableau BI application that's pointed to our secondary server. And that BI application will read that data instead of accessing the primary. We can now leverage the benefits of replica sets to replicate data geographically throughout our enterprise. We could store the primary servers near the applications and business units that update that data, but replicate the data to secondaries running at other sites. It doesn't have to be to different countries, it can be to different data centers. We can update the data in New York City, but we can replicate it to London and to Sydney. The applications in the remote locations can read the data from the secondaries, but they can traverse our network to update the data on the primary. Here's a quick overview of some other MongoDB features. MongoDB allows you to choose from different engines. MongoDB administrators are able to custom tailor MongoDB storage engines to fit the application's requirements. As a relational DBA, we know that proper indexing is important for fast data retrieval. MongoDB provides a primary key. It's called an object ID. It also provides standard single and multi-column indexes. But it also provides indexes that only contain index entries from fields that match filters contained in the expression. This allows administrators to create indexes with a much smaller set of stored values, which improves query performance. Another feature is TTL indexes, which allows users to choose the amount of time the data is stored by the database. Once that time limit's reached, MongoDB deletes the data automatically. Good example, sensor data. Maybe we have an application program that rolls up the detail sensor data and summarizes it, and we no longer need the detailed data. We can use that TTL setting to automatically purge that data from our MongoDB database. As a relational DBA, I also know it's important to enforce data validity. When we insert a value into our database, we can check to see if it meets a set of requirements. Well, for example, we may want a field to be mandatory. Each time we store a document, that field must be present. We can also validate the data according to a rule that we define. A good example would be an email address. We'd like to have an @ sign in the middle of it, and it needs to end at .com, .net, .biz, whatever we want to enforce. We also learned that we could lose our primary server and not be required to change the application code to point to the new primary server. One of the big benefits of MongoDB is it provides a BI connector. One of the challenges these NoSQL architectures have is because they don't store data in relational rows and columns, that they can't be accessed by a whole host of third-party SQL-based BI analytics products. MongoDB provides a BI connector, which allows the database to be viewed as a set of relational tables by SQL-based BI analytics platforms. This allows us to analyze data in MongoDB using those standard relational database analytics products. MongoDB also has a very strong security architecture, includes data encryption, FIPS compliance, support for LDAP. It also has a robust auditing mechanism. We can audit DML, DCL, and DDL operations. Well, now we talked about some of the MongoDB features and benefits. Let's move forward with the RDX MongoDB service offering. We've been providing database support for over 20 years now, and our goal is to provide that same support for MongoDB as we do for all other products we support. Since MongoDB may be relatively new to some of you, we'll also help our customers with proof of concept projects to kick the tires, so to speak. Our partnership with MongoDB Inc. will provide you, both of us, right, with additional expertise when needed. If our customers are interested to see if MongoDB is a good fit, our MongoDB team can meet with you to discuss. Like all other databases we support, RDX will provide a full suite of MongoDB database administration services. We'll help you design the architecture, convert data from existing applications, and make sure you leverage all of MongoDB's inherent feature set. We'll install the cluster systems, we'll patch and upgrade them. If they break, we'll work with a vendor, support when needed. We'll also leverage MongoDB's robust security mechanisms to safeguard your sensitive data. We're also going to make sure the database is easily recovered, highly available, and performing as expected. RDX is rolling out SolarWinds as our new monitoring product. We're in the process of testing our SolarWinds MongoDB monitoring templates now. Here's a deeper dive into some of the support services that RDX is going to offer. Application conversions, new application builds, all the standard support activities that good DBAs provide to support their systems. Space management, capacity planning, upgrades, patches, backup and recovery, performance and tuning. We'll help you with high availability and sharding. Increase your availability using Replica Sets, and we'll be using SolarWinds to monitor the MongoDB product. One of the big benefits of MongoDB's Agile schema is that it fosters rapid application development. Schema changes can go through iterations during the development process. We don't have to wait for schema changes to be made. Because you don't need a DBA to predefine the schemas for you, RDX is going to create a support relationship with our customers that ensure the database is being used effectively, but also allows you to fully leverage MongoDB's Agile development features. We'll offer advisory services on how the system should be architected, as well as recommend the initial document layout. But we learned that it's pretty easy for your development teams to change the document schemas throughout the development project lifecycle. Our goal is to assist our customers in leveraging MongoDB to speed application time to market. Our goal is we work with customers to ensure that process occurs. Here's what the current status of our offering is. We have experienced MongoDB DBAs on staff and are training additional resources to support them. We finalized our partnership with MongoDB Inc. at the beginning of this year. We have a lab environment that's sharded and contains several replica sets, and we're going to use SolarWinds to monitor MongoDB. SolarWinds monitors database apps using a collection of monitors called a template. RDX has templates for MongoDB as in the process of testing them. We expect our testing to be complete within the next 2 to 3 weeks. If you'd like more information on RDX MongoDB services, you can contact your primary DBA or any of the team members on the slide. Amber Lorenz, our client liaison manager, 412-208-1647. Our 2 sales team specialists that focus on MongoDB, Anthony Heckert at 412-205-6256, and Fred at 412-208-1683. You can always email me at cfoot@rdx.com. There's no E in foot, CFOOT@rdx.com. Or you can call me at 412-208-1635. Really, if you're interested in learning more about MongoDB and our service offering, you can contact anyone at RDX and we'll work with you and our sales team partners at MongoDB Inc. to provide you with the information you need. Here's just a quick overview of the benefits of our service offering that also pertain to MongoDB database support. You aren't buying the skill sets of a single DBA, you're buying the shared knowledge of a team of MongoDB specialists. RDX provides 100% onshore services, and we can custom tailor a MongoDB services package that meets your unique needs. I'd like to thank everyone for showing up for today's presentation. As I stated, if you're interested in learning more about MongoDB services or the product itself, give us a call and we'll respond to you as quickly as we can. Thank you very much.